And thank you all for attending the first ever SigOpt AI and HPC Summit. I am Michael McCourt, head of engineering here at SigOpt, and I want to express my excitement that we can host a session like this, even in a remote format. Last week, SigOpt celebrated our 7th birthday, and we have grown up a lot in that time. I have been here for 6.5 of those 7 years. I have always been proud of the work that we have done here at SigOpt and the product that we have served to our users. SigOpt's vision is to empower the world's experts. And today, we heard from experts in industry and academia that have used SigOpt for their own intelligent experimentation. We kicked off our talks today with SigOpt's general manager and co-founder, Scott Clark, who talked about the 3 key elements of intelligent experimentation: design, explore, optimize. Our first panel of the day included an in-depth discussion of the current state-of-the-art for graph neural networks. And I had no idea how big these graphs are nowadays. Somebody mentioned a graph of 100 million nodes not even being that big. That seems incredible to me. I'll be looking forward to the next big breakthrough for GNNs. In particular, Da Zheng was predicting it'll happen in search, recommender systems, maybe even drug discovery. Maybe we'll be hearing about that big breakthrough at the next SigOpt Summit. Our speaker sessions kicked off with Banu and Subrata from Mindtree talking about using SigOpt on transformers to improve results for their customers. We appreciate them staying online late into the day, all the way from India. I hope they got some sleep. Maybe they're awake joining us right now. Cheyenne and Alex from Accenture talked about how their work with LSTMs is improving predictive maintenance on oil rigs. This work is helping to improve safety on these oil extraction platforms, as well as helping to minimize environmental impact. Always a great goal. We heard from Pablo at Anastasia, who explained how SigOpt is helping his company bring time series to small and medium enterprises throughout South America and the rest of the world. In particular, this is an important step to making sure that these smaller companies can still leverage the powerful ML tools of massive corporations. Subrata from Numenta talked about how his company is trying to leverage insights about neuroscience to better design neural networks, which seems like a natural fit. Of course, that's where the original design of neural networks came from. His goal, however, is to make these neural networks as efficient as the human brain by introducing more sparsity. Personally, as somebody who grew up doing a lot of sparse matrix computations at Argonne National Labs, I love to see more sparsity making its way into neural networks. And let me take a moment here to call out that these first 4 talks were given by speakers in India, the UK, Chile, and the US. I find it amazing that SigOpt has this worldwide user base. In the middle of the day, we had a little networking session. We talked about the role that SigOpt plays in the sciences, whether through designing AI models, model calibration, solving inverse problems, or exploring design spaces. And in fact, Vishwanath spoke about how Novellus uses SigOpt to conduct an efficient design of experiment on recycling strategies. His talk explained how beverage cans are one of the most engineered devices in the world, next to only the space shuttle. And he also explained how SigOpt was helping improve that design process. I certainly appreciate all that hard work when I'm enjoying a cold beer. Our first academic speaker, Paul Liu from the University of Pittsburgh, spoke on how SigOpt provided a more efficient alternative to genetic algorithms when searching for the Pareto frontier in a materials design problem. In particular, he was able to additively manufacture glass to minimize reflection, which helps the performance of devices such as solar panels, cell phones, and maybe even your computer monitor. The next speaker is also working from a university. Rafael Gomez from MIT spoke about the work being done to connect scientific computing from first principles to scientific explorations utilizing machine learning. In particular, he discussed how multi-fidelity experimentation gives the opportunity to learn more quickly than by physically fabricating every model of interest. He also spoke on how SigOpt can be used to help solve inverse design problems in the molecular space. In reality, I think that this is just a really exciting topic because at Intel, there's a lot of importance for compute. Obviously, Intel is selling a lot of compute resources, and I'm really excited to see all our customers successfully taking advantage of their compute resources. Our second panel explored non-ML uses of SigOpt. One of the exciting parts of building SigOpt is its capacity to work in a broad set of fields. I mentioned earlier the sciences. We had both industry and academia speaking in this panel about how SigOpt can be used to design materials and structures in an efficient fashion. We also discussed the cultural shift in the experimental design community towards adaptive experimentation, away from the classic full factorial designs. We had an interesting discussion about what actions SigOpt and other players in the space can take to help facilitate that shift. An important shift because this design process also often involves extremely expensive fabrications or computational experiments. And the more sample efficient that these can be, the better the resulting materials will be. Alexander Johansson, currently studying ML at Stanford, spoke on the adaptation of language modeling to designing and interpreting protein strings. Now, before this talk, I'm not sure I'd ever heard the word proteomics before, but now I know how important it is. And again, it's just a really amazing use of AI to help improve research in the sciences, specifically medicine and therapeutics. We had a number of speakers from Intel, which is no surprise because since SigOpt's acquisition last year, we've been hard at work making sure that Intel practitioners can use SigOpt to its full potential. I want to take a moment now to thank everyone at Intel who has supported our integration into the company and helped us find our footing. You have made exciting events like this summit possible. I am just thrilled to be a part of it. Our first speaker from Intel, Ke Ding, talked about how SigOpt helped him more efficiently tune the deep learning recommendation model present in the ML-Perf benchmark series. He also spoke about how upcoming Intel hardware, including the highly anticipated Sapphire Rapids chip, has been designed to work efficiently on these extremely valuable ML platforms. We have two speakers from Havana Labs talking about how Havana is working hard from within Intel to improve the ML-Perf submissions. Basim and Evelyn spoke on the V1.0 of some of these submissions because the V1.1 is secret until the end of this month. They used SigOpt for HPO in order to speed up their model experimentation process. SigOpt's platform also gave them insights as to how hyperparameters may lead to very specific high-performing model behavior. David Austin spoke on a popular topic for many data scientists, Kaggle. He is a Kaggle Grand Master, and I loved hearing him give some thoughts on revisiting a competition where he was already the first place winner and improving the classification of ships or icebergs from very low resolution images. He described some best practices when conducting intelligent experimentation using SigOpt to improve upon his own high-performing baselines. Our final Intel speaker, Tian Tang, gave a very helpful survey of the state of recommender systems. And he explained how a new end-to-end solution his group had developed, which incorporates SigOpt, helps address some of the severe costs associated with developing recommender systems for citizen data scientists. Really exciting goal and something SigOpt, now free from within Intel, is definitely interested in supporting. And really, all in all, it's been a great day. Before I became the head of engineering, I started here at SigOpt as a research engineer. Research has been my passion for the entirety of my career. SigOpt gave me an opportunity to not just conduct research, but also put it in the hands of those who could most benefit from it, to empower the world's experts, so to speak. Years ago, when we had a more private, secretive group of SigOpt users, it wasn't always obvious that our research was actually helping them. It was difficult to know whether we were making a difference. But today we heard from experts regarding some of the work that SigOpt is supporting, building out time series models, graph neural networks, supporting drug discovery, materials design, improving recycling processes. And I can't fully express my excitement regarding all of the awesome work presented here today. And I also can't fully express my gratitude to the speakers for taking the time to speak about their SigOpt performance. I'm so glad to hear that you're having a great time with SigOpt, and everyone on the research team, everyone on the engineering team, everybody inside SigOpt is incredibly excited to hear about your experiences. Thank you. Let me also thank everyone out there who is a SigOpt user. You are why we keep pushing to make things better. Anyone who is not a SigOpt user, thank you for joining us today. I am psyched that you gave this summit a shot, and I hope that you give SigOpt a shot. It's free forever. Maybe we'll see you up here for our next summit. And personally, I want to thank everybody working at SigOpt for joining me on this journey. I also want to thank anyone still listening right now. You're still here after 10 hours of talks. Incredible. You're the best. Thank you all for attending the first SigOpt AI and HPC Summit. Take care.